Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors Chapter 8 Quiz Extra Practice Solutions. This is an answer checking anagrams puzzle. Let's go ahead and check that out. So here's a look at this puzzle. In this one, there's a whole bunch of questions having to do with sequences and series, and I actually gave the answers at the end of all of this down here. The trouble is, some of these answers are wrong. I think they are, let's look at the directions. They are exactly one digit of the answer is exactly one too high. So if there's like a 2 in there that should have been a 3, that's the issue going on. So the idea here is solve these problems and circle or write down the letters of the wrong answers, because all of these have letters instead of numbers for the problem identification label, and then unscramble those letters at the end to spell a word somewhat relevant to the idea of sequences and series. So with that in mind, let's start going through and seeing which of these has the wrong answers. So here we go with problem A. In this one, we need to find the 52nd term of the arithmetic sequence that begins with 7 followed by -3. So we're going to use the nth term formula, a sub n equals a1 plus d times n minus 1. And we're looking for a sub 52 here. So that's going to equal our first term of 7 plus, now the common difference, to get that, I have to take one term and figure out what I need to get the term after it, or I could find it by taking a term and subtracting the preceding term. So if I do -3 minus 7, for example, that's going to end up being -10, because I have to add -10 to 7 to get -3, and this is what I keep adding on this one. Now for my n value, that's the index of the term I want, so 52 in this case. So then that's 52 minus 1. And I'm going to go ahead and plug this in the calculator. So here we go with 7 minus 10 times 52 minus 1. And that all comes out to -503. Looking at my answer, -503 does not match -504. So this is one of those letters that we need to write down that will eventually be part of our answer at the end. So I'll put an A here, and I'll just start keeping track of the letters down here as we go. For problem C, we want the sum of this arithmetic series that begins with 1 and has a 31st term of -767. So let me use my arithmetic sum formula. That would be n times a1 plus a sub n all over 2. So in this case, we're finding the sum of 31, and that is going to be, the n value is 31 terms, a1 is 45, plus a sub n is -767. Let's just plug all that in the calculator. So I entered all this in my calculator, and if you're wondering how I got this fancy fraction mode, I do alpha y equals and then this n over d sort of option I can choose to get this. It won't be the last time I use this. I really like it because it takes care of all the PEMDAS for me. But if you need to, just be careful with your parentheses. So we've got -11,191 out of this mess. Glad I didn't try to do that in my head. And looking at my answer, that matches what I have for answer C, so it's on to the next. For this problem, I want the sum of the first 123 terms of this arithmetic series. So my sum formula, I've got n times a sub 1 plus a sub n over 2. I know my n value, that's the 123 here. I know a sub 1, that's the first thing in my list. I do not know the nth term, in this case the 123rd term. So before I can use this formula, I actually need to go back and find that 123rd term. I'll use the nth term formula, a1 plus d times n minus 1. This is for an arithmetic series, in order to find that. So I've got a sub 123 equaling a sub 1 is -13. My common difference, -15 minus -13 is really plus 13. So that's going to be, let's see here, 2 plus 13... No, -15 plus 13 is -2. So I'm adding -2 to get the next term each time. So I'll write -2 here for my d value. And then n in this case is 123. So 123 minus 1. And let's use the calculator to crank this out. Plug in all that in, we end up with -257. Next up, let me go back to my sum formula. So I had an n value of 123, a value, a sub 1 of negative 13, and now my a sub n, I had to find that was negative 257. Let me plug all this back in the calculator. There we go. Let's see what that equals. Enter. Negative 16,605. And E in the answers here, that's exactly what it says, so I don't get a letter out of this one, and we go on to problem G. For this one now, we are being asked for the 28th term of a geometric sequence, so different set of formulas. I'm going to use my nth term geometric formula here. That would be a sub n equals a sub 1 times r times n minus 1. So we've got a1 value of negative 5, r value of, well, let me think. To get 30 out of negative 5, 30 divided by negative 5 is negative 6. That's what I'm multiplying by each time. So r value of negative 6. And my n value, we've got 28, so we'll do 28 minus 1 for the exponent. Definitely doing this on the calculator. So here's what this looks like on my calculator. For the exponent, if you don't have an exponent mode that gives you superscript, you might want to have a parentheses around your exponent to make sure this all happens in exponent land and doesn't break any PEMDAS rules. So pressing enter on all this, I end up with something crazy, 5.117, we'll just stop it there, times, this e means times 10 to the 21st power. Let me look at what I have for an answer. Pretty close, actually, 6.117. So this is one of those one-off answers that I have to write down the letter to. So a G is going to be part of my final solution to this puzzle. On to the next. Next up, we have this sigma notation going on with some funky absolute value in there. This doesn't really fall into any of our categories of arithmetic or geometric. I guess arithmetic would be the closest kind of series that this is, but because we have the absolute value, that's going to mess things up a little bit if you're trying to find a consistent pattern. So I'm just going to plug this in from negative 3 to 1, write this series out, and just add it up by hand. So we have a negative absolute value of negative 3 times negative 3 is my first n value. Negative 3 times negative 3 is 9, so this is negative absolute value of 9. Next up, we have negative 2 going in there. That gives me a 6 inside the absolute value, so minus absolute value of 6. After that, we're plugging in negative 1 times negative 3 gives me a 3 in there. And then I have 0. Negative 3 times 0 is just 0, so minus absolute value of 0. And then finally, we're plugging in 1, so that's just negative 3 inside the absolute value. All right, so we have a negative 9, a negative 6, and that's, let's see, another negative 3. That's a grand total of negative 18 so far. This 0 doesn't really matter. This is subtracting another 3 because this becomes a positive 3, but then the negative out here, we're subtracting positive 3. So negative 18 minus 3 gives us a grand total of negative 21. But feel free to verify that on the calculator. Taking a look at my answer for I, it says negative 31. So we're one number in one digit off here. So that's an I that we're going to be writing down for our answer bank. For problem M, this one's a little bit of a beast, another sigma notation. I'm going to start this one off by just writing out the first few terms to see if I can see an easy pattern. So we've got 4 times 5 to the, let's see, our first k value is 2 that we're plugging in. So 4 times 5 squared, 4 times 25 is 100. Next up, I'm plugging in 3 for k. 5 to the third is 125. 4 times that is 500. And then after that, we've got, this would be 5 to the fourth, that would be 625. Times 4 would give us even more, I think 2,500. Yep. And then we just keep going. Eventually, we make it to 4 times 5 to the 36. All right, so what kind of series is this? Well, I noticed that each of these are getting multiplied by another 5. That's really the only difference as we move up in this series. So this is geometric. We have a common ratio of 5. So writing a few things down, first let me write my geometric ratio formula. for the sum of a geometric series. So that would be a sub 1 times 1 minus r to the n all over 1 minus r. My first term, my a sub 1, is this 100 that we wrote up here. For my r value, that's what I'm multiplying by each time. In this case, that's 5. And then for n, that's the number of terms in this series. Now, I didn't write them all out, and I wouldn't feel like counting them even if I did. But we're starting at 2, and we're counting to 36. Now, if we were starting at 1 and counting to 36, that would be 36 items. Since we're starting at 2, that's 35 instead. Or as a quick trick, you can do 36 minus 2, and then we automatically subtract, let's see, or add 1. We automatically add 1 to whatever that difference between the limits is. So we have 35 for the n value. So writing all this out, that's going to be 100 times 1 minus 5 to the 35 all over 1 minus 5, and I will absolutely use the calculator on this. So here's what I've entered in the calculator using my fancy fraction mode. Press enter. We get about 7.276 times 10 to the 25th. Looking at my answer, it seems we've got 7.276 times 10 to the 26, not 25th, so that's different. So let me write down m as another one. So that's like 3 in a row. Let's see if we can keep this up. On this next problem, we're trying to rewrite this series using sigma notation. So let me do my sigma notation here, my sigma symbol. And before I do that, though, let me see the pattern, because that'll help me write the summand for this. So 1/2, 1/4, 1/8, and so on and so forth. It looks like these are all powers of 1/2. They're all 1/2 to some exponent. So writing this, I can write this as sigma of, we'll say 1/2 to the n power. And now the first n that I should plug in to get this initial 1/2, I would like to do 1/2 to the 1 power. So let me say n equals 1 there. To get the final term here, 1 over 32, that would be 1/2 to the 5th power. So let me put 5 up here. And that is it, nothing else. Looking at my answer down here, yep, we've got 1, 5, 1/2 to the n, sigma, check. So n is correct, on to the next. For this one, we're trying to figure out if this geometric series converges or diverges. And if it does converge, we want to give the sum. So to do this, the easiest way would be to just look at the common ratio and see if that's less than 1, less than or equal to 1, or more than 1 in any of those. So in this case, if we do 5 over 5/4, that'll give us the common ratio, taking one term and dividing by the term before it. Or you could just do 20 divided by 5. That seems like it would be much easier, but hey, we're here now. So 5 times flipping and multiplying 5/4 gives us 4. So our common ratio is 4. Now 4 is greater than or equal to 1. The absolute value of 4 is greater than or equal to 1. That's the true test. If that is the case, then this series keeps getting bigger and bigger and bigger, or at least further and further and further away from a central number. So we would say that this diverges then. And diverging is what we have in Q. I'm not sure how that answer would be one off anyway, following the pattern of this puzzle. So Q doesn't give us anything. For letter R, again, we're trying to figure out if a series converges or diverges and give the sum. In this case, we have, let's see here, an A1 of 1/3. My R value, if I do 1/12 divided by 1/3, that would be 1/12 times 3 over 1, 3 over 12 then, which is 1/4. So we're multiplying by 1/4 each time to get the next term, and 1/4 times 12 is 1 over 48, so that works out. Since the absolute value of 1/4 is less than 1, we would say that this is going to converge. That's the test. And since it converges, we can find its sum using our formula, a sub 1 over 1 minus r. So this is going to be 1/3 over 1 minus 1/4. So 1/3 over 3/4 if you do 4 over 4 minus 1 over 4. This is really 1 over 3 times 4 over 3 if we same change flip that thing, and that comes out to 4/9. So 4/9, looking at my answer here, converges 4/9. Yep, that all matches up. For problem S, we are being given the sum of a geometric series and also the first term, and they're asking us to work backwards and find the common ratio. So to start this, let me set up my formula. S equals 1 over, or rather A1, A sub 1 over 1 minus R. So I know my S value, that's 3 over 7. My A sub 1 they gave me was 5. And then we have 1 minus R. We're trying to figure out R here. So I'm going to cross multiply in this case. So I'll have a 35 if I do 7 times 5. And I'll also, if I distribute here, have 30 minus 30R on the left side. So a whole bunch of cross multiplying happening. Then I can subtract 30 from both sides. So that's 5 over on the right side. And now if I divide both sides by negative 30 to get R by itself, 5 over negative 3 is going to reduce to negative 1 over 6. Negative 1 over 6 is not what we have in S here. They have negative 1 over 7, so I think that counts as being 1 off, kind of, sort of. So I'm going to write down an S then. For problem T, they're giving us a function, and they want us to write the first 4 terms and general term of a power series to represent this function, and then identify the interval of convergence. So just using my general setup as thinking of this as a geometric sum, what I'm going to do is write down my first term and my common ratio. So the general formula for the infinite series of a sum is a sub 1 over 1 minus r. So 7 is in the a sub 1 spot, so I'll call my a1 7. And then x squared is in the r spot. It's 1 minus x squared instead of 1 minus r. So I'm going to say my r value is x squared. And with these problems, it's okay if it's a variable instead of a constant. This is considered a constant, perhaps, for our purposes anyway. So getting my first term, I've got 7. That was easy enough. And then to get the rest of the terms, I have to keep multiplying by x squared. So we have a plus 7x squared plus 7x to the, let me think, I add the exponents, so that's x to the 4th. And then we have 7x to the 6th, and so on and so forth. In general, I'm doing 7x to the, let me think here, if this is like the 0th term, then I would want 7x to the, or 7 to the, 7x to the 2 times n. Because if I plug in 0, this would just give me 7. If I plug in 1, I have x squared, and that would be it. Plugging in 2, I'd have x to the 2 times 2, so x to the 4th. So it looks like that works out. Now for the interval of convergence, I have to take my common ratio and set it less than 1 in the absolute value. If I square root both sides, I can write absolute value of x is less than 1. And I don't have to worry about a plus or minus when I do that, because the absolute value of something can't be less than a negative number anyway. Now I can rewrite this as negative 1 less than x less than 1. And that would be my interval of convergence. So taking a look at all of this stuff, checking it closely, it looks like every detail matches. So we go on to the final question. For question U, they're asking me to write a function of x represented by this geometric series. So let me first clean this up a little bit and move all of this into one exponential term by writing negative parentheses x minus 3, all of that raised to the nth power. So what I'm going to do in general is rewrite this using the sum of an infinite geometric series formula. So in this case, my a1 is going to be 1, because if I plug 0 in for n here, anything to the 0 is just 1. Now what am I multiplying by each time? Well, it's whatever's inside this nth power term. So negative x to the, or negative parentheses x minus 3 is my r value. In general formula, we have a sub 1 over 1 minus r. So in this case, that's going to be a 1 over 1 minus negative x minus 3, which is really 1 plus x minus 3. And then if I combine the 1 and the negative 3, that's going to be negative 2. So 1 over x minus 2 would be my final answer. Looking at my answer choice, that is exactly what I've got there. So it looks like this one works. So after having done all of those problems, these are the 5 letters I've collected of answer choices that were incorrect. So let me rearrange these to spell something that might be relevant to sequences and series. So let me think here. I've got an S, I've got an I, I've got a G, M, and A. That spells sigma. So that'll do it. Until next time, Mr. Sutton, signing off here. I'll sigma you later.